Okay, so I'm going to be going over how to configure multiple networks with multiple routers, in this case just two, on how to get them to communicate with each other. It's not that hard of a process, but I've had some trouble figuring it out, and I firmly believe that if I can explain this, then I'm probably good to go for the exam, because I figured this next exam is going to have a lot to do on static routes and stuff. And I know I'm not the only one who's been struggling with this, so yeah, this should help anybody who is. So we're going to create a simple little network here, technically 3 networks. We're going to put 2 2811 routers. We're going to have 2 network switches here and here. And then we're going to have 2 PCs on each. You probably want to look at like having a wireless access point, because that was on Lab 6 as well. And we are using Lab 6 as kind of like a template for this. This is going to be a longer video. I'm sorry, but this is just kind of an involved process. But this is our basic topology for the network for now. Let's go ahead and let's connect all these PCs to the network switches. I'm thinking we just use some copper cables like this. Pretty easy for now. Nothing that should be hard or new. Okay. So now once these computers are all connected to the switches, we're going to connect the switches to the routers. There's not really a correct port here. You'll just have to remember which port it is, right? I mean, there are ways to see, and I'll show you that later, which ports specifically. But yeah, for now, these will be red. That's fine. That's expected. So don't panic about that. We're going to go into the routers. I did it really quick here on the first one, but I'll show you a little bit more in detail in a second. We want to connect these 2 routers with fiber. So we're going to click into this router. We're going to shut it off because you can't add components to a router, or you shouldn't, when it's running. We're going to find this nm-1fe-fx module and just drag it into this slot, which will give us a fiber link, and turn the router back on. In the exam, it might ask you to do other things. It might ask to add other ports beyond this. Just know that there's a bunch of different modules in here, and you can add pretty much whatever you want as long as it's a module. Okay, so now let's take some fiber and let's connect the 2 routers together. All right, so because we're using Lab 6 as a template for this, we're going to pull up Lab 6 here and go off of this. So there's 3 networks in this, and I'm going to go ahead and I'm going to draw those networks quickly for you. So there's one, whoops, I have no idea why that's not working anymore. See, that's working. And it's not erasing. That's going to trigger me so hard. Okay. Can I delete it? No. Okay. Well, awesome. I don't know how to get rid of that. Yes. Ah, it's gone. Okay. So let's create these 3 networks in a way that's really easy to visualize. So, as we know, basically in this case, the routers are separating the networks. So we have one network here, we have one network here, and we have one network here in the middle with this fiber line. So we're going to label these networks. This is going to take us a minute, but I promise it'll make our lives a lot easier later. According to the lab, this network is 11.11.11.0, right? And these 2 ports on either side are going to be assigned 11.11.11.1 and 11.11.11.254. So it'll look like that. This is our first network. Let's label it as such. Network 1. Okay. This is a network. Actually, we'll make this network 1. And this will be network 2 over here. And then this middle one will be network 3. I don't know why that just makes more sense to me, because these are the two networks that things are actually happening on. And then network 3 is just kind of the intermediary network between the two of them. It's not an intermediary device, but it is, in a way of thinking, an intermediary network, because it's just combining the two, or connecting the two together. That's all that's happening. So we're going to make another one here. This network 1, is 192.168.10.0. And then this router, let's leave it at that for a second. This router's port. So this is, we'll put this up here along with this network 1 network address right there. Now, this network, this port is going to be 192.168.10.1. And over here, we're going to just do it at the same time, 192.168.20.1. I'm just going to quickly network. This is the 192.168.20.0 network. This is our network address, right? If that makes sense. This address does not necessarily reference any device, any specific device on this network. This is just the network address for the whole network. Same with this one. Whereas the .0 signifies the network, whereas any specific .1, .2, whatever references the device or the port in this case. So let's go ahead here, and we're going to assign this switch 192.168.10.2. And this network switch is going to be 192.168.20.2. And then each of these, PC0 and PC1, will be 192.168.10.3 and the same 192.168.10.4 for each of these PCs here. Make sense? Okay. Now, PC2, I know there's a lot of setup here, guys. I promise this, I wouldn't normally do this when I was setting this stuff up, but for the purposes of this video, though, it's going to make our lives a whole lot easier to visualize what is happening and what I'm doing. 20.4. So these are all of the network addresses for everything. Now, in the case of these computers, these network addresses are referencing to specific devices. Technically, that's not true. Technically, it's always a port that you're referencing with a network address. But in this case, because there's only one port, you can pretty much say that this network address belongs to this device. However, when we get up to like this router, it's got multiple ports, and multiple ports can have multiple different IP addresses, and we will be using that in this situation. This isn't an exact replica of the lab. You'll see that if you do the lab, but it's pretty close. So what we're going to do here is we're first going to configure the computers. I find it easiest just to start from the bottom and work your way up, and to verify every step of the way that everything's working properly. So this is PC 0, which we assigned the IP address of 192.168.10.3. It'll auto-populate the subnet mask. That won't always happen, but it should usually happen. So this default gateway section, though, is a little different. We do need to populate this or else this will not work. Basically what's happening here is we're telling the computer to exit this network. What port do we want to talk to? And in this case, it's this port right here, this one, that connects the router to the switch on the router side, that is. For now, that's all we need to configure for PC 0. PC 1, 2, and 3 will be pretty much the same process, just typing in the respective IP addresses. I am going to not fast forward through this, though, because seeing it over and over is just going to cement that, right? So 10.10, sorry, no, that's wrong. That was a one I was doing earlier. 168.10.1 is the default gateway. You'll notice that even though the IP address on this device is different, because it's on the same network, the default gateway remains the same, right? So now we're going to go to these PCs, and we're going to do the exact same thing. 192.168.20.3 and 192.168.20.1. Because we are on this network now, this PC is on this network, the default gateway changes to this port here, right? That's pretty much all you need to know for now for that. We're just going to 192.168.20.4. I believe it's 4. Let's just double check that. It is. And the default gateway is also 192.168.20.1 because it's on the network, the same network as this first PC. So first we're going to configure these routers. The way I'm going to do it, I kind of set it up this way so that I just had to connect to each PC. I didn't have to keep changing the console connection where the console's connected to. Kind of did that on purpose. You don't need 2 computers on each network for this to work. Technically, you can ping from switches, so you don't even technically need any computers on the network for this to work. But for the sake of not driving myself insane of, connecting this console line to the router and then I need to do the switch, so let's move it to switch. No, that's just too much time. I'm also going to practice doing this in a way that you would actually have to do it in the real world. So we're not going to try to go into the CLI of the switches or anything. We're going to access them from these computers because that's what you would need to do in the real world. So first we're going to configure the switches. Go to the terminal. We're going to enter the terminal using enable, go into privilege mode, I believe. And now we're going to go, or privilege exec mode, that's what it is. And then we're going to go config terminal. So we want to configure this switch to allow for communications. So first step there is we're going to go interface VLAN 1. We're now configuring VLAN 1, and we want to assign VLAN 1 the IP address of the switch. So 192.168.10.2, and we need the default gateway as well. And now that that has been assigned, that IP address has been assigned to the VLAN, we're going to just activate it with no shutdown. You can see it's up now, and we're going to go in this PC and we're going to attempt to ping the switch. Basically, this is my way of showing you that communication is now being facilitated between the PCs and the switch. This is a working, more or less, network, and I want to show you that. It might fail the first time, That's a-okay. That's normal. It has to send out some ARP requests. But as you can see, we're getting replies. Now if we ping it again, because we won't have to send out that ARP, it'll immediately reply. So now we're going to do the same thing quickly on this switch, just so that we don't skip over anything. Whoops. Oh, good. This is a great example of why you should not do that. And in fact, I don't remember what the keyboard shortcut is, so we're going to have to quickly use ChatGPT to figure this out. Cisco iOS keyboard shortcut to stop translating. Control-Shift-6 apparently. Yeah, that's it. Okay. And that is why you should go config T and go no IP, I believe it's IP address dash lookup. I don't remember at the moment. It might not be in configuration mode. It might be in privileged exec. Let's quickly try it. No IP address lookup. It might actually be a little different than that. I don't know. I'm not going to waste my time on this because it's not the point of this video. We're just going to configure the switch. So in this case, we do want to go config T. And then we want to interface with VLAN 1 again. And we want to assign the IP address of 192.168.20.2. And the subnet mask. And activate it by typing it down, typing in no shut. And in theory, we should now be able to send pings to the switch from one of these computers. Might take a second. Yeah, there we go. We're getting replies. Perfect. Okay, so even though the switch can communicate with the PCs, now we're going to get into getting these switches to communicate with the routers. Let me just think here for a second. Right. Okay. So, right. Okay. So our next step, we need to set a default gateway on the switch itself. I don't actually think we need to do this to communicate with the routers right away. This is technically a next step thing for the step we're going to be doing after this one. But it's just kind of good practice, in my opinion, to do it now. So we're just going to type in IP default dash gateway. And then we're going to give it the IP address of the default gateway, 192.168.10.1. I believe we need a subnet mask. We do not. Okay, well, that's good to know. And that's pretty much all we need to do on either of these for now. Not that one, this one. Exit. Into, oops, IP default gateway 192.168.20.1, and we're done. Okay, so now we're going to go ahead and we're going to configure this router. So in the router, we're going to access it through PC0 since that's the computer that's connected to it. We're going to hit no for this configuration dialog thing. We don't need to worry about that right now. We're going to get into the router the same way, using the same commands that we would on a switch. And now we want to tell this port to activate. This one here that connects on the router to the switch. So we're going to go FA interface, FA, I believe it's 0, 0. It is. Whoops. Right, int FA 0/0. That'll take us into the configuration of that port. We're going to assign it the IP address of 192.168.10. This is the port that is our assigned or designated as our default gateway. And of course, I forgot to type the first part there. So IP address 192.168.10.1 and then the subnet mask. We're going to activate it by typing down no shut, and we're going to just confirm that everything's working by typing in show IP interface brief. You can see that that port is up and working. You can also now see that this has turned green, meaning there's an active connection between the switch and the router. Let's quickly do that on this router. Shouldn't take as long this time. Enable, oh my gosh, Control Shift 6, yes. Enable config T. Interface, I know that I cabled this up the same way as the other one, so it's interface fast Ethernet 00. And then IP address 192.168.20.1, right? And we need the subnet mask and no shut. And we can see that once again, this is now up and working. So we can go into one of these PCs and we can actually ping our default gateway to make sure that it is working the way we want it to. And you can see it immediately responds. Let's do the same thing on this one. .20.1. It also immediately responds. So the next step is we need to activate this network. We need to get this working. It's not that hard. It's quite simple, actually. A note that I will quickly tell you when I am doing this. Actually, I won't tell you quite yet. I'll show you in a second here. Okay, we're going to go back into the configuration terminal. And now we have to interface with the port that is here, right? FA1/0. Okay, so now we're interfacing with that port. What we need to do is we need to activate it. We need to assign it an IP address actually first. IP address, in this case, this port should be designated 11.11.11.1 with the appropriate subnet mask. And we want to activate it by typing down no shut. So you can see that it changed its state to up. We're going to do the same thing on this other router. While I'm doing that though, hopefully I can multitask here and say one thing while doing another. I'm going to tell you how this is not actually always what you're going to be doing. In this case, we're using fiber, and in most cases in the real world, you're probably going to be using fiber or maybe Ethernet to connect to routers. Now, one sec here, FA1/0. Oh my goodness, I can't type. However, if you're using something like, what is this here? Serial DCE, you probably have to set up the clock on the router itself. Have the two routers synchronized for them to talk accordingly. For fiber, that's not something you need to do, so we're not doing it in this video since our instructor has told us that we're pretty much just always going to use fiber. You should know how to do that though, even if you are using fiber. And of course, there's a lot of configuration on the switches and the routers that I've skipped, like, you know, setting up the VTY lines and the passwords and stuff like that, that you would do in the real world. But for this, we're just showing you how to configure these networks to get them to communicate. So we're not dealing with any of that. Anyway, we're going to assign an IP address. In this case, it's 11.11.11.254 with, of course, the appropriate subnet mask. No shut activates the port, and you can now see that these two are working. They're talking to each other. However, there's a problem. You would assume, I assumed the first time I did this, that this 192.168.10.1, or sorry, 10.0 network can communicate with this .20.0 network. That is not the case. This router is only actually aware of two networks, network 3 and network 1. This right router is only aware of .20.0 and, or rather, network 2 and network 3. Because they are not directly connected, these two networks have no idea that the other exists. So network 1 doesn't know anything about network 2, and network 2 doesn't know anything about network 1. So what we need to do is we need to go into these routers and we need to set what's called a static route. There are other versions of routing, like I believe it's dynamic routes. We haven't gone over that yet though, and I don't know how to set them up. So we're not going to deal with that. We're not going to worry about it. However, the static route is what we're going to deal with today. So we're going to go into PC0. We're going to go terminal. We're going to go into the into the router. Okay, so in, I believe it's configuration mode. I think it's configuration mode. We're going to set an IP route. Now, the way that you do this is kind of tricky to wrap your head around at first, but I promise it's not that hard. You're going to need two different network addresses. One of them does include the subnet mask, the other does not. So we are currently interfacing with 192.168.10.0. We're interfacing with network 1's router. We want to tell it to access network 2. So we're going to give it network 2's network address, not any device on the network, just the network address. We're going to provide it with the subnet mask of that network, and then we're going to tell it, remember, actually before I tell you this last thing, remember, this router knows that this router exists. It's directly connected to it. What it doesn't know is what's beyond that router. So it knows that this port is 11.11.11.254, right? So we can tell it to access this network through this port, which it is aware of. It knows it exists. So let me just make this a way that we can see it here. So in IP route, we're going to type in the network we want to connect to. So 192.168.20.0. We're going to give it that network subnet mask. And then we're going to tell it that we want it to connect through this port, 11.11.11.254. That's it. That's all you need to do. You don't need to type in no shut, nothing like that. we're going to do the same thing on this PC here. However, because this is a different network we're trying to connect to, it's going to be different IP addresses that we're using. I'm shrinking this window so we can see it. Right? Oh crap, don't do that. Okay, there we go. All right. We actually don't need that. Okay, this is fine. Okay. So, in configuration mode, we're going to type in IP route, and we're going to type in the network address. So 192.168.10.0 for this network 1 network address. We're going to give it that network's subnet mask, and then we're going to tell it that to access that network, you're going to want to interface with this port, 11.11.11.1. And that, in theory, is all we need to do. This should be fully working now. We're going to go to PC0, and we're going to type in some ping commands. We're not going to immediately go to network 2. I want to kind of take it slow. So we've already tried, we already know that it can connect to this switch. We're not going to do that again. We're going to try and ping this router, which I think we've already done, but you can see it immediately replies. No loss, nothing. Again, with these, you can expect longer ARP requests, especially the more hops in the chain you need to take. So if it fails even the first ping command entirely, try it again, it might work. I've seen that happen before. In Packet Tracer, that is. So, I actually don't want to ping. So we know that it can access this router. We want to see if it can access this router. So we're going to ping this router with 11.11.11.254. It might take a second. That's totally okay. You can see it timed out there, and we're getting replies. So that ARP request took however long this first ping took. It took too long to actually get a ping back. Actually, I think it just ignores the first ping. Oh no, we didn't want to. We did not want to close that. Okay, so now that we know that it can access this router, we want to be able to confirm that it can access this network. So in theory, this switch shouldn't need to send an ARP request for it to do its thing, but we'll see. We'll just go directly to one of these PCs. So it's 192.168.20. Let's do PC3. And let's see how long. That's interesting. Reply from that destination host unreachable. Let's try the switch. .168.20.2. Okay, we're getting replies. Okay, so we're going to try pinging that PC again. It could be that I typed it in wrong. This is why it's always good to check multiple things. If you do 2 hops at once and it fails, it could be as simple as you typed it in wrong and we're too stupid to go back and look at it. Let's try pinging that computer again. Might take a second, might even fail the first ping. It did, but you can see we're getting pings back from PC3. And we're pinging it from PC0. Now, I'm not totally sure, to be completely honest with you, if verifying communication in one direction also verifies it in the other. I think it does. But it's never a bad idea to go to this other PC on network 2 and verify connectivity there as well. So we're going to, from PC3 here, we're going to verify that we can connect to PC0. 192.168.10.3. And it does. You can see that since all the ARP requests, all the MAC address tables have been filled out accordingly, the first time we went through, it doesn't even drop one. You don't even have to send out any ARP requests. It just knows immediately where to send the packets. So I hope this helps anybody who needed help with this. This was like a few hours of me trying to figure it out. I don't know why I couldn't. You have to be really careful with these IP addresses. If you mess one up, it won't know what to do. So don't do that. If you do need help, let me know. I'm by no means a wizard at this. I'm just learning this and trying to help you guys along too. So, yeah.